The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, and welcome to this live learning event entitled, What You Don't Know About Infiltration in Sewers is Costing Millions. My name is Don Rigby, Director of Marketing for Avanti International, and today I have the pleasure of introducing to you some pretty savvy people and facilitate this session to maximize the next 59 minutes for you. The common practice of letting infrastructure wear out before replacing it, rather than incorporating technological improvements during its lifetime, only exacerbates the problem. And many thanks to American Society of Civil Engineers for establishing this greater purpose for this live learning event. The platform we're using has all participants on mute, but it's important we get interactive, and here's how we'll get there. First of all, I sent out over 100 emails to folks pre-registered with the intent of getting some advanced knowledge of the single most important learning objective for this webinar. And we've got some responses, and we'll incorporate those into this presentation, making this time well invested and relevant to all. So, before, during, and after, you will have questions, and that's a good thing. We'll reserve time at the end for Q&A, but I recommend as questions come to mind, immediately type them into the collapsible dialog box to the right of your screen. As appropriate, I'll interrupt the speaker or choose to reserve it for the end. If we don't get to all the questions in this webcast, we'll answer every question individually by email, and that's a promise. So let me introduce to you our experts today. Daniel McGill began working at Avanti International in 1992 and assumed the role of president of the company in 2008. Headquartered near Houston, Texas, Avanti is the largest U.S. supplier of chemical grouts serving the municipal, industrial, and geotechnical markets. Mr. McGill has a bachelor's degree from the University of Houston and a master's degree from Penn State University. Daniel's also chairman of the Rehab Zone, a trenchless technology educational forum within the UCT conference, which is coming up January 28th at the Houston Convention Center. Daniel, that's coming up pretty quick. Are you ready for that?
I'm ready. I'm looking forward to it.
Are you ready for today?
Yes, sir, I am.
Ron Manistar has been with Aries Industries for 16 years as a service manager for the Southeast United States and opened up Aries' new facility in Atlanta last year. Ron has invested hours in the field optimizing operations and troubleshooting equipment, and he conducts training seminars for municipalities and contractors on TV inspection and chemical grouting techniques. Ron, you ready to share your experience today?
Yes, I am.
Awesome. And Mark Anktel is president of Logiball, headquartered in Quebec, Ontario. He's also president of ICGA, Infiltration Control Grouting Association, a division of NASCO, of which he was also past president. Mark, are you feeling presidential today?
I'm ready to go.
All right, one last bit of information. There will be 3 interactive poll questions asked during this session, and these are very interesting because I play back the answers right away, and you'll see how your reply stacks up to others. More important, these poll questions will drive our presentation. So let's get interactive, and let's do the first one right now. And I will find the right buttons here and launch the first poll. And it should be showing right now. The question is, what is the principal cause of underground infrastructure decay? I'm going to ask for your single best answer, either infiltration, inflow, neglect, poor construction, rain events. Choose a single best answer. Good responses coming in. Got about 60%, 70% of the vote. I'm going to shut it down and share the response back with each of you. So let's close it and share. 25% infiltration, 53% neglect, poor construction, rain events. Well, Folks, I think the answer to this question may be all of these. But to start us off, I'd like for Mark to set the stage and share an insightful presentation on the demise of buried infrastructure. Mark, I'm going to make you presenter, and I thank you for taking off from here.
Thank you, Don. Thank you for attending, ladies and gentlemen. Let's start off with what we have in the ground today. Many years ago, as a civilized country and population, we decided to build sewers. And of course, these sewers are underground, so we have to dig trenches to lay the pipes in the ground. Practices back then and today are a little different, but we still have to bury this infrastructure. There's an estimated 5 billion feet of sewer in the U.S., and basically, if we cut this down, we're looking probably somewhere around 2 billion feet of collection piping, another 2 billion feet of service piping, and 2 billion or more joints in the sewer mains and the lateral piping. We see here is basically a gentleman that is laying pipe in this trench, and he is pouring tar over the joints to make these watertight. There were no gaskets back then. There were different practices that were accepted, and one of these is basically pouring tar over the joints and making sure that it would seal up. Up to the 1970s, there was very little, either none, static pressure testing or inspection of the work that was being done. So we may have a little of everything down there. The trench is basically what we see here with the bedding. This is only one trench. There's multiple trenches underground, okay? And all these eventually meet somewhere and make it easier for any groundwater to travel within a man-made trench than the native soil. Once again, technologies for sealing the joints as applied here. Could have been cement or tar. These trenches make it easier, once again, for any water that's coming either sideways or along it or above it to follow these channels along our piping system. Here's a little overview of our collection system. We have our manholes, our piping, our transmission lines, everything's for pump stations. They're being pumped to the treatment plant, treated, and back to the outfall. Some of our systems are underwater. When I say underwater is we have groundwater that's present on a low end of the system, okay? If groundwater is there and it penetrates into the system, well, it can surcharge our system, creating all the negative effects of SSOs or flowing back into the homes, basement floodings, etc. So we don't want that. Here's a famous EPA drawing from the 1990s. We've basically updated, or not updated, but made it a little more visible for us to understand what's going on. So here's our storm trench. Here's our sewer trench, and usually the storm trench is at a higher elevation in the ground than the sanitary. We have our manholes that basically allow some water to come in. We have storm sewers that are not always airtight or watertight. Even when they're put in, there's more standard practices now that are requiring these to be air tested or even visual inspection of non-leaking after they've been installed. We have our foundation drains here. We have inflow that may be coming in, maybe a sump pump. We've got problems with the sewers with root penetration, cracked or broken pipes, defective service connections, name it. All these are buried infrastructure, and at some point where there are joints here, will allow groundwater to come in. There's another side view. Basically, if we have a rain event, water basically will go along the trench of the storm sewer, eventually finds its way into the sanitary, overloads the system, creating issues. Issues that we know of above ground, or when we see manhole covers where we have water coming out, not always a nice view. Another picture of this, our catch basins, storm sewers. We have great, everything's going towards the storm sewer, trying to get the water away from the house or homes. into our piping systems. Okay, our foundation drains, storm drain, sanitary sewers, all this well embedded in man-made trenches. Here's a view of something that not a lot of people may think of, but if you put cameras in the storm or sanitary sewers and you are seeing pipe shifting left and right, or you've got offset joints, you're going down the pipe and basically up, down, left, right, not a barrel anymore. Problem may not be the pipe, but the bedding around the pipe, okay, where it is either bad compaction or it's been washed in or washed out into the sewer system, not providing any more support for the joints. Okay, this tar or cement does not last forever, so it may allow some groundwater to come in, okay, or storm from storm sewer, find its way here, and basically start degrading our bedding. Here's that famous storm event. Okay, water going, storm sewer. We get groundwater also at the same time. We have infiltration come into our sewer system, overloading the system. Here's what looks above ground. How many times have we seen this? Here's a backyard. Here's our storm sewer gulping everything down from the street, asphalt. Our sanitary sewers are over flooding. One, basically, I'm not saying leads to the other, but we can visually see consequences above ground and just imagine what's going on underground. Here's our famous graph. We have this storm event, the inflow along with groundwater. This is where we get to our peak, where groundwater eventually percolates into the ground. This is where we have a smoother line here. That rainfall or groundwater saturated soil finds its way into our collection system, and eventually the flows go back down to what they were before the rain event. Okay. So we surcharge our systems after rain events when we have infiltration coming into these pipes. Okay, you see here exfiltration. Why is there exfiltration here? Well, all this storm sewer into the trench will find its way into the sanitary trench, overload it. Okay, then we get exfiltration where we have sewer water going out into the soil. As that rain event eventually stops, okay, you may get infiltration. What we're seeing here is still the exfiltration, where our sewer system is overloaded. Okay, but as time goes by, what happens? Well, now we have infiltration. What this is, movement of water coming into the system, coming out due to our bedding. Well, we may have fines that also come in. Okay, we're washing out around the joints, around the connections, that we will be creating areas of no more backfill or very loose backfill. So now that our system is back and going down normally, that groundwater that's saturated the soil is now coming in. Originally we had an overload going out. Now we have groundwater coming in. And that's on a long curve that we saw after that high rain event. So this is going on, saturated soils, okay, our catchments, everything here. We have our exfiltration, infiltration, so movement of water in and out of the joints to eventually, basically, this is what we're seeing, the cutout. What used to be supported may not be supported as well anymore, as the fines may have washed into our sewer system. If you're down in Florida, sometimes you'll see there's as much sand coming in as water. Okay? Same thing can happen. And if left unattended, well, all these millions of dollars that we've put into the ground without maintaining or trying to sustain these systems, we can get failures in the long run. Failures may be due to preventing that water from coming in. Okay? I can talk to you about failures here. I've personally witnessed this. But it's our responsibility to maintain and sustain these investments. A few examples of what we can see. Here's a manhole allowing groundwater to come in. I mean, this is probably extreme, but it is out there. All you've got to do is basically, excuse the expression, but pop up a few manhole covers and have a look after a rain event. Infiltration at the joint, same thing, and at service connections. So all the points of entry into our collection systems that we can come out and fix using chemical grouts when it's not structural issues. This is a very nice drawing. This is our piping system, no problems. We have a joint that allows groundwater to come in or groundwater or sewage water to go out when we're in surcharge. And basically all of the fines come in, okay, around or adjacent to the joint. Right now we're getting into a structural problem at stage 3. Well, chemical grouts are not structural. They are designed to go out into the soil and seal the soil adjacent to these. So it can be used at stage 1 or stage 2. Multiple technologies out there: dig, replace, fold and form, sectional lining, pipe bursting, cured in place, and chemical grouting. You've got structural repairs here, and you have chemical grouting, which is the only technology that's designed to stop groundwater from the inside and sealing the soil around the issues. So how can you get the most return on your investment? Daniel McGill next, please.
Okay, thanks, Mark. Hopefully you all are seeing my screen here, and I've got grout chemistry fundamentals. I'll talk a little bit about the chemistry and why acrylic grouts in particular are used in municipal applications. First, let's define what is a chemical grout. It's the injection of a multi-component resin into voids around the pipe and or structure. It doesn't matter what the structure is. It could be a wet well, a lift station, or a manhole. But the goal is to stop infiltration, exfiltration, stabilize the surrounding soil, stabilize the pipe, and seal the annulus between the hose pipe and the liner. And Mark, you showed this diagram. I think it's great. It shows the 4 points of entry, and it's very significant to address all 4 points of entry, because if you only stop the infiltration at 2 here, at the mainline joints, where does the groundwater go? It follows the path of least resistance and starts to come in the next point of entry, which might be at the lateral connection or up the lateral or even around the manhole. Here it shows number 4, just most of the lateral grouting happens 2 to 3 feet into the lateral, but they've gone up to 30 feet up the lateral in one shot. So you can vary it depending on what your local standards are. And they started using municipal grouts in municipal applications in the 1960s. So we consider it a permanent solution. This is what they call the grout donut. This was from an 8-inch pipe they dug up some 25 years after it had been grouted. And this donut is what stops the exfiltration and the infiltration. And we consider it permanent because the U.S. Department of Energy did testing on 7 different types of grouts over a 20-year period. And they gave acrylamide a 362-year half-life in the soil. They ultimately used it to encapsulate radioactive waste, but they really wanted a long-term solution to stop the groundwater from leaching that waste into local streams. So there was a question that was sent in prior to the webinar from Mike Cardwell in Westland, Oregon. Mike, thanks for the question. It addressed wet-dry cycling and also infiltration at laterals. So regarding wet-dry cycling, it can go through wet-dry cycles. If you have a cup of cured grout on your desk, it will start to shrink. And when you add water to it, it'll come back out. And it'll do that over and over and over again. If you allowed it to totally dry out, then it wouldn't come back. But as long as there's some humidity or some moisture in the soil, it'll keep the grout happy. And there is groundwater outside the pipe. That's why you're grouting in the first place. And then there's sewage inside the pipe. So between both of those, they'll keep the grout happy. We sell the same product that's used in municipal markets here. We sell into Egypt, where it's a very arid climate, arid soils, and there's enough moisture in the soil to keep the grout from shrinking and shriveling up. And there they're using it to stop water coming into large tunnels. Primary municipal grouts include acrylics and polyurethanes, and the acrylic family breaks down into acrylamide grout, NMA or acrylic, and acrylate grouts. And the main difference between those is the amount of acrylamide in each one. The urethane family breaks into hydrophilics or hydrophobics, which really addresses whether or not it can go through wet-dry cycles. It can be a gel or an expansive foam, and it can cure flexibly or rigidly. The reason acrylics are primarily used in municipal grouting is they're the thinnest products on the market. If you have a cup of acrylamide grout sitting next to a cup of water, you cannot tell the difference. Water is 1 centipoise. Acrylamide grout is about 1.2 or 1.5. I mean, you really can't tell. There's no suspended solid, so whereas cement can only go as far into the soil as the particle size will allow it, there are no suspended particles in acrylic grout, so they can go anywhere water goes. Field adjustable cure times, the contractor or the municipality can change the cure time anywhere from 5 seconds up to 14 hours in the field. They can adjust the gel strength when they have high levels of infiltration. They can use soap and water for cleanup. The grouts are not activated by moisture. That's helpful. There's no need for solvents, and there's a successful track record. Like I said, there are case studies that date back to the 1960s. If you look on the right here, that blob in the center of the graphic, that's actually a betta fish. And then at the top of the sand, there's a dark layer. That's grout in the sand. We took some acrylamide grout, poured it into the sand. We knew it had a 10-second cure time. And it only was able to percolate down about 1.5 inches before it cured and became a solid. And then if you notice at the very bottom, all the sand is dry. And we wanted to create a good visual here for a couple of different purposes. One, it's been 3.5 years now, and that sand is still dry on the bottom. And two, the fish above it is just fine. We get lots of questions about, oh, there's acrylamide's toxic and it's in the grout. Well, it's important, compare it to other things. For example, caffeine and aspirin are more toxic than the acrylamide in chemical grout. So all that to say is that it's less toxic than things that we use every day. So it's important to keep it into context. And with that, I'll pass it on to Ron.
All right. Well, I would also like to thank everybody for attending this Grout's webinar. I'm going to discuss the processes about grout. And the processes, when they are done correctly, will yield predictable outcomes. And these processes include the cleaning, inspection, assessment, prioritization, and the rehabilitation of the systems. Now, with the sewer cleaning, basically a vacuum truck will position itself over a manhole and with a jet nozzle move the debris and fine sands to the manhole where the materials will be vacuumed out of the system. Yeah. Okay. Now, the inspection process, we have a CCTV camera mounted on a robotic crawler, and that is controlled remotely by an operator. The crawler travels through the pipeline, and the operator documents the observations or defects codes according to the PACP codes. In the assessment process, the coded observations or defects will help determine if the line segment has infiltration or structural issues. The collected data will be used to set the priorities within the collection system for rehabilitation. Once everything gets prioritized within the catch basin, you need to follow the category of structural repair or maintenance of a non-structural repair. In the rehabilitation, we have structural repair or non-structural. If it's a structural repair requiring pipe replacement, pipe bursting, or even a lining project may be needed for the rehab work. In a non-structural repair, chemical grout is a process by which a joint or a connection is tested and sealed by a packer. That pressure injects chemical grout through a pathway into the surrounding soil, and an air test is performed to validate the repair. Now, in the grouting process, it involves 3 steps: test, seal, and validate. In the testing portion, the operator will pull a packer and a camera through the line segment, pressure testing every joint. A pressure transducer mounted to the packer can measure the void pressures and electrically transmit the reading back to digital readout on the control panel, where the operator can see that the joint passes or fails an air test. In the sealing process, all of the failing joints are pressure injected with chemical grout to refusal. We use the pathway in the failed joint to inject chemical grout into the soil, whereby we make a soil grout substrate that will stop infiltration of groundwater. We then validate that the joint repair was done by conducting a retest of the chemically sealed joint with another air test and confirm that the joint passes the test. These 3 steps will ensure that a grouting project is done properly and according to the ASTM specifications. Record keeping. This information is necessary for us to record for future review and to evaluate that the grouting processes were followed. Here we have 2 documents, the grout mix data sheet and the sewer test seal work data sheet. On the first document, the data that is collected includes information on the contract, the municipality, and the work to be performed. It also includes information on the sewer pipe, information like pipe diameter, materials, and the lateral pipe information. Here we have the test and seal packer information. Information is collected on the type of packer being used, mainline or lateral, and the size of the packer and the void volume, the effective sealing length of the lateral bladder. A little further down is the grout sealing chemical mix. There is information on tank size, the batch size that is mixed, and a percent solids and the gel time of the mix. This information is necessary to confirm that the chemicals were mixed according to the manufacturer specifications. On the second page is a sewer test, seal, and data worksheet. The information collected here is for the specific line that is being worked on. It has all the information, who's performing the repair, the location of the basin, and the project that is taking place, basically the city and street name, upstream manhole and downstream numbers. But also we have the test and seal joint and lateral record. This includes information on the footage, if the joint passes or fails an air test, how many gallons were pumped, and if it was pumped to refusal, the cure time, and if the joint passed or failed a retest. On our first animation, here we see groundwater entering the sewer system through a joint. The camera and packer are positioned over the joint, and an air test is performed. Upon failure of the air test, chemical grout is injected under pressure through the pathway into the surrounding soil to stop the infiltration and to stabilize the area adjacent to the joint. A second air test is performed to confirm that the repair had been made, and then the process was repeated on the next joint. On animation 2, here we see a main line with infiltration and a lateral connection. A liner is installed for a structural repair.
Hey, Ron,
now we have to reinstate.
Ron, can I ask
Yes?
you to hold for a second? Let the PowerPoint catch up to you real quick.
Oh, okay. Where are we at on it?
We're now doing the sealed lateral. Go ahead.
Okay, the sealed ladder. We have the main line with infiltration and a lateral connection. A liner is installed for a structural repair, and then the packer is rotated into position. A lateral bladder is inflated, and an air test is performed. Once it is failed, chemical grout is injected up the lateral connection through the annulus and out the defects in the pipe. A second air test is performed to confirm that the process was done properly. The lateral bladder is vacuumed back into the packer, and then the operator will continue on to the next connection.
Yep. If you'll hold that there for a moment. I want to ask a question from the audience, and I think I'd like to direct this to Daniel. And I know you'll have a crisp answer for this, Daniel. Why not use urethanes in main lines and laterals, I think, versus acrylamides? or the acronym?
Yeah, great question. Urethanes are more often used in cracks as expansive foams or void fill, but in the main lines, urethanes are moisture activated. That means that you run the higher risk of grouting up your hoses. Since acrylics are not moisture activated, urethanes could grout up your hoses. And then also when they cure, they're very sticky, and they slowly get thicker and thicker, whereas acrylics stay water-like and then all of a sudden turn into a solid, so they can penetrate farther. It would also be much more expensive to grout main lines and laterals with, I say much more. It might be somewhat more expensive to use urethanes, but I think it mainly comes down to the sticky.
Good. Daniel, thank you. There's a lot of questions coming in, so we have no problem filling the Q&A process. But if there's other questions that come to mind later on, folks, please submit, and we'll get to them all. I'd like to launch one more poll question, and it'll help drive the next presentation. In municipal grouting, what standard operating procedures exist? And in this case, check all that apply. Check all that you recognize as sources of standard procedures. Yeah, it looks like we're getting answers fast and furious, fast and furious. Look at that. This is going to require a little more time. I got about 40%, 50% of the vote in. I'll certainly give it more time. I'm going to close it in about 10 seconds. I'm going to close it right now. And I'll share. As I suspected, ASTM came in, but you're right. Every one of these organizations are responsible for driving some operating standards for all of us as guidelines, and which leads me to my next presenter, and that would be Mark. And Mark, in a multi-vendor world, the stage of what you talk about next is going to be really relevant. So I appreciate you.
Perfect. All right. Well, if you move to the next slide, please.
Yes,
okay.
Sir.
The importance of industry standards. Well, there's multiple pieces of equipment and techniques here that come into one situation. Is basically to stop that groundwater from coming in. So there are test and seal packers. There are
Mark, you do me a favor and press that button to show my screen.
TV and grouting unit. If I start, well, the first thing we want to make sure is that the chemicals are going to perform as we want them to, as needed. So it's important to have chemicals that are not biodegradable, that will react in the presence of active running water, and that will perform in these cases. So there are standards on the chemicals being used. On the delivery equipment, if we're looking at the CCTV ground truck, we have to make sure that we can pump these chemicals out at a certain gallons per minute, depending on what we're doing. We need to make sure that the monitoring system for the void pressure, whether it be air testing or chemical pumping in the void, can give us information in the truck. What are these pressures? Or how many gallons am I pumping out? Okay? So all this, including compressors in there, must be unified to give you the performance that's required. The same goes with the packers. You have mainline packers. You need to make sure that the operators or the ones working with these packers will know the voids between that packer and the wall. Why is that? Because that gives you information on how long it takes to fill the void so that you can now work with your gel time and get the materials on the outside of the pipe in a reasonable amount of time. All these are very important. So they must be unified. So there's standards. Why are there standards? Well, best practices exist to give us a pathway to success. If it's not something that needs to be repeated, then it's not a standard. A standard is something that's basic that we need to follow. Sure, sometimes we can derive from them slightly according to field conditions, okay? But there has to be a minimum repeatable performance from all these components, the delivery system, the chemicals, the tools or packers, to obtain success. So best practices are developed by industry experts to obtain the best results possible on job sites, not in the office. Standards for chemical grouting. Back in the early 2000s, many of us got together. And when I say many of us, I'm talking manufacturers, contractors, engineers, municipalities, and interested parties around ASTMs, and came up with, the first one was actually mainline sealing, okay, standard practice for sewers used in sealing sewers used in chemical grouting. This is a long process, and it's a thought-through process. These ASTM standards are being revised on a 5-year basis. Took us actually 2 years to get the first standards out for us to agree on basically standard practices. Main lines, laterals, and manholes were basically the standards developed through ASTM. As of last year, NASCA, which is the National Association of Sewer Service Companies, has a division called ICGA, which is Infiltration Control Grouting Association. A group of people got together, decided, okay, we need to make something that is more, that can be used out there by the engineers, by the municipalities, so that they have a basically a standard specification that they can use either for themselves or for bid work, determining what needs to be verified or not. Okay, and this is a 19-page document, and it's been out in the marketplace, I'd say, for about just a little over a year, and we are seeing this document, which is a very well-defined document, by the way, and I encourage you to read it once you're done, to basically field practices. What do we need to verify?
We will be sending that to everybody as a result of their attendance here.
Perfect. So you'll get a copy of this afterwards. So very important. Encourage you to read through it. And with that done, it's all yours.
All right, Daniel, I'm going to make you presenter. And let's hope this one goes a little smoother.
Okay, I clicked the button. We're on first trenchless technology. Okay, so I've been tasked with talking a little bit about ROI, return on investment. We get that question a lot from engineers in particular. And this says, you've come a long way, baby, because chemical grouting is actually the original trenchless technology. They started using the grouts, acrylic grouts, in the 1950s in the U.S., in the 60s for municipal applications. So they've been around for a long time. Here's a cover of the suggested standard specification that Mark was talking about that everyone will receive. But 40 years ago, they didn't have this spec. So we've come a long way in that regard. And certainly the impact of public works is now, because there's that spec and institutions or organizations like NASCO, municipalities have a way to know how to grout correctly, how to make a batch of grout correctly. Inspectors know what they're looking for and that the work can be done consistently and correctly. The impact for communities is that the less money the cities spend on treating groundwater unnecessarily, then the taxpayer dollars certainly go farther. I'll look at just 3 quick case studies. This is Miami-Dade County, certainly one of the largest water and wastewater systems in the U.S. They have a low topography, high water table, highly transmissive geology. Basically, that means there's a lot of sand underground there, so water moves freely through it. You can see where the flood zones are here by the blue circles. They started a grouting program, or an I&I program, about 25 years ago now, and they've reduced their flow 128 million gallons per day, which to me is amazing. And certainly that's not all due to grouting. Grouting is one tool in their toolbox as part of their I&I reduction program. But they will tell you that it's the best bang for the buck. For every dollar they spend on grouting, they have a $2.50 cost avoidance savings. And so it's a tool that they use when there's not a structural problem and they're just focusing on stopping infiltration. Downers Grove, there was a webinar on Downers Grove just a couple of weeks ago in Illinois. After grouting, they saw a decrease of 21% in their infiltration. And what's more significant is that they were going to spend $30 million on collection system upgrades and new treatment capacity, but instead they spent $3 million on some maintenance operations to stop the infiltration. So they saved $27 million with their in cost avoidance with their grouting program. And then finally, this is a case history for the city of Sunrise in Florida. And there's a lot of text on here, but if you look at the graphics to the left, you can tell that what they're doing is grouting a mainline joint. And what they had here, they had 700,000 gallons a day of flow. It was a 500-foot section of pipe. The joints were every 5 feet. And the failure rate of the joints was 100%. So every single joint failed an air test. And they used 7 gallons of grout per joint at a cost of about $6 per gallon. So they invested about $4 grand for their chemical grout. Now at the time they were spending $2.16 per 1,000 gallons to treat that groundwater. So if you take the cost of the grout or the investment in their grout and divide it by what they were spending every day to treat the groundwater, they made their money back in 3.8 days, and the city saved $480,000 just that year. This is a quote from Dr. Vipul Lanandan. He's the chair of the Civil and Environmental Engineering at the University of Houston. He says, to date, the only proven method of stopping infiltration is the application of chemical grout based on cost effectiveness, durability, and method of leak repair. Incidentally, he's also the head of SIGMAT, the Center for Innovative Grouting Materials and Technology, and he's got a conference every year in Houston. If you haven't attended that, it's a great show. With that,
if you'll hold that screen real quick, Daniel, I'll go ahead and launch another poll question. It's the last one.
okay.
It's the one that will set up discussion for the next presentation from Ron. This one reads, in your opinion, chemical grouting for municipalities is, and I want you to choose just one answer, single best answer. And I will share the results. I will share the results here shortly. We're about 35%, 40% in. Single best answer makes it tough. 65%. I'm going to go ahead and close this poll, and I'll share the response, and it may not surprise you. All the above took the prize. And to set up a discussion here that I think is pretty interesting, I'd like to make Ron the presenter.
Now here's a question. Is chemical grouting a maintenance operation or an engineering project? I'm going to bring a couple of points up on the maintenance area. Chemical grouting can be used in a structural trenchless technology rehab project. Grout is used to control the unwanted water that could jeopardize the successful installation of a trenchless technology. Also, grout is the most cost-effective method to eliminate infiltration of groundwater and the fine sands and stabilize a structurally sound pipe. In a manhole rehabilitation project, pressure injecting grout behind a manhole structure is used again to control the water from entering the manhole structure before a new coating or even a lining is installed. Is chemical grouting an engineered construction project? While we need to look at chemical grout as an engineered construction project, we need to look at the entire basin. We want to see repeatable, predictable performance in order to obtain quantifiable results using the process of chemical grouting. When we grout the manhole structures, test and seal each joint and lateral connection within a collection system or basin, we can measure the results by looking at the data collected from our pump stations to our flow meters and the treatment plant. We can see a reduction in operational hours at our stations and a measurable reduction of flow going past our meters and a decrease in gallons of water entering the treatment plant. If we are following a systematic approach to chemical grouting, we can demonstrate that chemical grouting is both a municipal maintenance operation and an engineering construction project. Our investment by using chemical grout and a systematic approach will return measurable savings in dollars within our collection system and treatment process.
There was a reference made to PACP codes. I think, Mark, you may have referenced that, PACP codes. Could you respond to a question from one of our attendees? Explain what PACP code is, please.
PACP codes is a uniform coding dictionary used to basically code what we're seeing while you're doing some TV work down in the pipes. Within PACP, there are grout codes that are being used while chemical grouting is being performed. PACP basically belongs to NASCO, the National Association of Sewer Service Companies, and it's a widely accepted, nationally accepted coding system for defects.
And Mark, while you're on a roll, what type of pipes can be sealed with chemical grout?
Basically any structurally sound pipe, whether it be storm or sanitary, anything that's not bricks, by what I'm saying pipes, because usually I'm saying we need to send some remote equipment like packers. Elliptical pipes, box culverts, 12 feet in diameter. But as long as they're structurally sound and there's a pathway to get the materials out, shouldn't be a problem to get the materials out through clay, concrete, PVC, worst part, cast iron.
Thanks, Mark. And Ron, if you'll respond to this one real quick, how are the chemicals pumped?
Basically, we have 2 tanks in the truck at 30 gallons each. So we have a mix of 60 gallons for one batch. And the chemicals are drawn out through a pumping system, which is 1-to-1 ratio, and then pumped down into the hose system, down through the hoses into a packer. And at the packer point is where the 2 chemicals, parts A and B, will mix together in the void, and then pressure forces or injects the chemical through the pathways into the surrounding soil.
Thank you for the crispness. Daniel, I got one for you here. Will adding latex strengthen my grout affect the, while adding latex to strengthen my grout, will it affect the gel time?
The short answer is no. There are additives you can use to control future root growth, to lower the freezing temperature. Latex is something that people use to give more tensile strength if there's movement or there's larger size backfill outside the pipe. It'll give a little more tensile strength. It will not affect the gel time. The only thing that will affect gel time is the amount of grout in the batch. If there's more grout, it'll make it cure faster. The amount of catalyst in the batch, and then also the temperature. If you're grouting in higher temperatures, it'll react faster, and you can. And vice versa, if you're grouting in colder temperatures, it'll react slower, and you can adjust your gel time with catalyst.
Dan, you may be the right person to answer this one too. What is the expected service life of chemical grout joint and or lateral repair? What is the expected life?
The short answer is it should last the life of the structure. You know, again, with the DOE testing saying 362-year half-life, it's going to last a long time in the ground. If you're an inspector or an owner, you need to make sure that the contractor or your municipal worker is mixing the grout properly and following the spec, because it can be a great product, but if you're not using it properly, then that's going to shorten the lifespan. But it should at least last the life of the structure.
Here's a question from Mr. Hill. Ron showed ejecting grout behind a structural liner. That was in the animation, Ron. Please discuss circumstances where grouting would be completed before a liner is inverted in the host pipe.
Well, when you're looking at that situation, you want to reduce the infiltration coming into the host pipe. Sometimes the water may wash out the resins on a liner. If the pressure is great in a deep line segment, you could have groundwater that's pushing onto the liner quite strong, and you may actually have bubbles or dips into the liner. And it may not even sometimes cure properly at that time. but in one section only. Okay.
What is the best way to bid out air testing and grouting of joints? What's the best way to bid that? And who might be the best person to, Mark, is that something you feel comfortable answering?
Yeah, typically what I've seen over the years is there's usually a price for a bid price for testing and a bid price for sealing. A lot of the times in the test and seal, the gallons of grout that were being pumped were all the responsibility of the contractor, but with the new suggested standards, we're seeing more and more where it's a shared responsibility between the owner or engineer and the contractor, where after a certain amount of grout that's being pumped in the soil, because we don't know the soil conditions, then becomes the owner's responsibility, or share at least a portion of it. So there's a price for testing and sealing, and somewhat for the grout, depending on how many is actually being pumped. And the owners, usually the contractors know the area where they're working in, but still, it's always flipping a coin on the amount of grout you're pumping. Typically, we're looking at about a quarter to half a gallon per inch diameter pipe on joints. And services, they can give an idea of maybe somewhere around 3 to 5 gallons of grout plus a gallon per vertical foot from the connection.
That was pretty, Mark, that was
Short
pretty
answer.
for that. But I'm at a place now where I'm starting to get sensitive to time, and when we ask for an hour of your time, I want to stop it at that. And we will answer more of the additional questions that we have by email, and I'm sure you're okay with that. So I'd like to stop this presentation at this moment and suggest to you that we love teaching exactly what we know and believe about stopping infiltration, about chemical grouting, and the only thing that we like better than webinars is teaching nose to nose and belly to belly. There is a hands-on training opportunity at Avanti headquarters in Texas, Webster, Texas to be exact. It's in January. And we are going to focus on injecting chemical grout into main lines, manholes, and laterals, and we're going to focus on some equipment operations, troubleshooting, and maintenance. And I've grown to respect the value of that part of the presentation. I spent considerable time on a truck in recent day, and I'm just amazed how important that is to keep productivity up. So if you are interested in becoming a student of chemical grouting, I would suggest that you review this opportunity, and as a result of your participation today, I'm going to send you some information about this, among other things, including these promise documents from NASCO and this white paper from ICGA. And it is 3 o'clock, and I'd like for my presenters, if you would please, Daniel, leading with you, just a couple closing comments is appreciated.
I'll just say thanks, Don, for your hosting, and Ron and Mark, pleasure to present with you. And everyone, thanks for your interest and time. If you have questions and you can't find answers on any of our 3 websites, then give us a call, and we'll help you to the best of our abilities.
And Ron.
I'd like to thank everybody for participating in this webinar. Once again, if you have any questions, please feel free to call us at our 800 numbers, and we'd be more than happy to answer any questions. Thank you.
And Mark.
Thank you for attending. Hopefully we've answered some of your questions or went through some details that make it a little more interesting for you. And I hope to see you down at the annual Grout School in Webster, Texas to find out more. Thank you.
And as you exit this webinar, you'll be asked a few questions, and if you feel you were well served over this last hour, please let us know. We fully intend to be the best in the business at these live learning events, and your feedback will tell us how. So, again, my name is Don Rigby, and I thank you so much for attending and for your questions. And until the next time, I'll say so long.